Question number 5. A ball of mass m collides with a stationary ball of mass 3m. Ball of mass m collides with a stationary ball of mass 3m, and as a result of it, after colliding, both the masses start moving with the same velocity. What kind of problem is this? Collisions. The moment is a collision, conservation of momentum should be applied. Okay, there is no problem without conservation of momentum, so you should know this. Okay, now what is here? This is moving with a ball of mass m collides with stationary ball. After collision, stationary ball. So this is at rest. This is at rest. This is moving at velocity. After colliding, what is the percentage loss in kinetic energy of the system? Okay, so what we'll do is he is asking you kinetic energy. First, what is the kinetic energy of this one here? Kinetic energy of this one is nothing but half mv square. What is the kinetic energy of this one? 0, because it's not moving at all. What is the kinetic energy of this? This is your kinetic energy final, which should now be equal to half into total mass. Don't multiply. Total mass m plus cm, 4m into. Now this is going at the new velocity. Let us say v dash or maybe v2. Right, v2. Okay, so v2 square over here. Okay, so what is that we require? Percentage loss. What do you mean by percentage loss? Kinetic energy final minus kinetic energy initial divided by kinetic energy initial. That's what is percentage loss, which I can write this as half into this is 4m v2 square, right? 4m into v2 square minus half m v square divided by half into mv square. This is what I get. But you know, we have this v2. As I already told you, whenever it's a collision, conservation of momentum should be applied. So how do I apply? Now what we have, this is m into v. This is your initial momentum. What's your final momentum? M plus 3m, 4m multiplied by v2. v2, m and m goes away. You get v2 is equal to v by 4. So we have got an expression for v2. So we will substitute it over here. And now what we do is we substitute it over here. So we get this as half into 4m. I'll write like this only. And then v2 square. What did we get for v2? v2 we got v by 4. v by 4, it should be v square by 16 minus. So half I have taken outside. So it should be mv square over here divided by half mv square over here. Okay, this half goes away here. So what do I have here? So you have 4 1s are 4 4s are. Thus I can now write this as mv square is common here, right? I'll write mv square into 1 by 4 minus 1 divided by mv square. This goes away. So what do we get? 1 by 4 minus 1 is equal to how much? Minus 3 by 4. Minus 3 by 4 is what? Negative 75, 0.75. Minus 0.75. This is only relative. Percentage if I want, I will just multiply this by 100, which will get to 75%, right? You can say negative 75%. What does negative tell you? Decrease in energy. So the right answer is D. Let us look at the other options. It's incorrect, so D is the right answer.